All right, what we're having a look at here is factoring non-monic quadratics. And I'm going to give you two methods. This video will explain one method and go through a couple of examples. I'll then do a second video with a couple more examples in there. You can choose to use whichever method you would like. I'm just giving you two options. You might wish to learn both or just one of them, but that's really up to you. So when we say a quadratic, we could be looking at something that looks like this. We could say x squared plus 8x plus 12. And we're looking for numbers that multiply to give 12, add to give 8. Pause if you'd like to have a go, but I'm going to run in straight away and say it's x plus 6, x plus 2. So numbers that multiply to give that constant term and add to give that term. Now we've looked at lots of different varieties of this where we have some negatives in there. We might have a negative x and a negative constant term as well. But what we want to look at now is something that looks like this. 3x squared plus 4x plus 1. Now, we have a little issue because previously we were looking for numbers that multiplied to give this middle term, and sorry, other way around, we were looking for numbers that add to give this middle term and multiply to give this end term. But in this case, we don't have any numbers that multiply to give 1 that add to give 4. The only integers that add to give 1 are 1 and 1, which certainly doesn't add to 4. But that's because we've got this 3 at the front. Now, don't get mixed up with something that might have a common factor. So let's say if we had, let's take this one up here up the top, and I said that was 3x squared plus 24x plus 36. Well, that's different. I could say 3 outside of x squared plus 8x plus 12. That's not a non-monic example because I can remove the common factor. Here there's no common factor. This 3 isn't common in terms of this 4 and the 1 as well. So we need an approach. So our first approach is this. We're going to call it an educated guess and check. And that's all factorising really is in this process. As you get better at it and you do more of it, well then there's less guessing and more knowing as you look at it more quickly. But still, for harder questions, you're always really just guessing and checking in an educated way. So what multiplies for me to give 3x squared? I'm looking at whole numbers as well. Well, I can multiply 3x and x. And what multiplies, or the factors of 1 are 1 times 1. So I know in my brackets here, I'm going to have, it's a quadratic, so I'm going to be able to factor it to something like that. I know I'm going to have 3x times x for that first jump. Okay, for that first, if I did my FOIL expansion to get 3x squared, I'm going to have 3x multiplied by x. And in the same way, to get my last numbers, I'm going to have 1 times 1. Now this one is actually quite nice because the 1 is positive and the 4x is positive, so we can just throw a couple of positive signs in there. Now, something to mention is that this is factored. Okay, so you would stop here. That is your factorization. 3x plus 1, x plus 1. But just to check in this case, I'm going to say I've got 3x squared plus 3x plus x plus 1, which gives me 3x squared, yes, 4x, correct, and 1. Obviously, this is just for a check. I've seen some of you who are going and factoring and expanding and factoring and expanding and just kind of going back and forth. We don't need to do that. I'm only doing this here as a check while I'm practicing, and you can do that mentally if you would like as well, just to make sure you've got things in the right order. Let's do one more. Okay, let's say that I've got 2x squared minus 11x plus 5. Okay, well, again, I don't have a common factor. That should be the thing that we check each time. Do I have a common factor? No, I don't. In fact, none of these terms share a common factor other than 1. No good taking out a negative for me. So, what multiplies to give 2x squared? Well, that's 2x times x. So that means my first term in the pair of brackets must be 2x, and it must be x. Because again, when I do that first step of my expansion, that one, I need to have 2x multiplied by x. And again, what are the factors of 5? Well, that's 5 times 1. So in my brackets, I need 5 and 1. Now, the thing here is that we have two options. In our last one, our numbers were 1 and 1. So it didn't really matter where we put them. Here we have options. We have either 2x and 5, and x and 1, or we have 2x and 1, x and 5. Now, the other thing I can look at here and say, well, this is negative, but this is positive. Okay, so I'm going to have two negative numbers here, because what I've got is that if I have two negative numbers multiplying, I will end up with a positive answer here, but when they added together, I end up with a negative there. So whichever way around I have them, it's going to be all negatives. So let's just check. We know our 2x times x is going to give me 2x squared. We know our minus 5 times minus 1 will give me 5. I'm interested in getting this guy right. The 11x is what we need to, minus 11x, sorry, is what we need to get correct. What I would have here is 2x times minus 1. So that would be minus 2x. Minus 5 times x is minus 5x. Well, that gives me minus 7x. And that's wrong. That's not what we want. So we'll check this one anyway, but our second option here is going to be right. This one will give me minus 10x minus x, which does give me minus 11x. We are correct. So this one is not my factorization. It's wrong, but this one, however, is correct. So that means that 2x squared minus 11x plus 5 is equal to 2x plus 1, sorry, 2x minus 1, x minus 5. Okay, so, and again, as always, we could expand to check, but if you're confident that you've got it right, please don't go and write down here equals 2x squared minus 11x plus 5 and then refactor or something like that. You'll stop there. Okay, can I encourage you to watch the second video as well, just to see what the second method is, and you can have your pick.